Now we want to look at probability distribution for pulling out different colors out of a bag that contains green balls, red balls, and blue colored balls. And the other day we did a probability distribution with a family of having 3 kids and seeing the probability distribution for having boys in that family. So now we want to have probability distribution. These are all independent events, and so we're going to be using multiplication as we do this. So we have 2 colors, or 2 red ones. We have, we have 4 red ones. And then we have 2 green ones. And we have 3 blue. Oops. Okay, so we want to create our tree diagram so that we only have to, we're drawing out 2, and so we're only going to, when we had 3 children, we had 3 stages, if you will. So this is the first draw. And we're going to start, this in order of what we're doing. And so the first time we pull something out, we could pull out a green color. And if we pull out a green color, we have a 2 out of a total of 9 possibilities. So we could have done that, or we could have pulled out a red color ball. And if we did that, we have 4 of those out of 9. Or lastly, we could pull out a blue one. So we could have pulled out a green, or a red one, or a blue one, and the blue one would be 3 out of 9 is the probability for that. So there we have our, let's suppose we picked out a green one the first time. So now, after we picked out that green one, okay, and we set it aside, we are going to next pull out a green. We could pull out a red, or we could pull out a blue. And if we pull out a green, I've already pulled one out, so that leaves me with 1 and only 8 remaining. If I pulled out a green the first time and a red the second time, that's 4 of them out of 8. And if I pull out a blue, so I pulled out a green the first time, I'm going to pull out a blue the second time, so that's 3 out of 8. So you can go ahead and finish these branches and then check in just a minute. Okay, you can double check your work. If we pulled out a red one the very first draw, then pulled out a green one, we still have 2 green ones in there, so 2 out of 8. We pull out a red one the second time, we've already pulled out 1 red, so now we have 3 out of 8. We pulled out a red, so the blue would be 3 out of 8. Okay, so this is the first part of this. And then if we notice that we really want to make a probability distribution for 2 of the red color balls. So what we want to do is find out what the probability of 2 red, and again, notice this is an and statement because it's the understood. If you don't see the word or, then you know it's an and. So you have 2 reds. So if I have 2 reds, then the next, maybe it's 1 red and some other color. And then the probability of 0 reds. And so in the end, I'm going to have to end up with 78. I'm sorry, not 78. It will be 72 out of 72. I'll explain that in just a minute. So 2 reds, so I'm looking for the branch that has 2 reds. So 4 out of 9 times 3 out of 8. Now 1 red, so that would be a green and a red. So 2 out of 9 times 4 out of 8. So that's 1 red. I have 1 red here. one red here. Oh, I'm sorry, that's two reds. So I have one red, then I have one red here and one red here. So 4 out of 9. So it's this branch, or, so that's addition, this branch, 4 out of 9, times 2 out of 8. Or, so that's two reds, I want one red, so 4 ninths and 3 eighths. 4 ninths and 3 eighths. So we have that one red, this has one red, this has one red, and then the blue and red is the last one, so one more, or 3 out of 9 times 4 out of 8. And so 0 reds, and on the PowerPoint you'll see the rest of it, but notice 4 times 3, this is going to be 12 out of 72, and so when you add all these up you should end up to be 72 out of 72. So if you jump back to the PowerPoint, you'll see the breakdown of all of them, and they're color-coded there for you. So when we add up these fractions, 40 plus 20 plus 12 is going to be 72 out of 72.